Alright, for worksheet 3, we're going to actually create a table, and then from the table, draw our graph, and then once we've drawn our graph, we're going to see if we can find all these values that we found up in worksheet 2. Alright, so for -3, and you can actually take the calculator and plug these into the calculator. You don't have to do it by hand, but I'm just going to show you how you would do it by hand. So we have y equals whatever x is squared plus 2. So if x is -3, you would have 9 plus 2 equals 11. Alright, and then for -2, -2 squared is 4 plus 2 is 6. Like I said, it's okay. You can use the table function on the graphing calculator, but I do want you to fill in the table and actually do the points from the table rather than just trying to draw it freehand from the graph on the graphing calculator. Okay, so I went ahead and filled in this table here, and we're going to actually graph these points. So -3, 11, -3 goes off the graph just a little bit. Okay, just up above by 1. -2, 6, -2, 6, -1, 3, -0, 2, 1, 3. As you'll notice, these points, 2, 6, the same points on the other side, 3, 11. If we draw our parabola carefully, we're going to see that it's almost the same parabola, but it's just shifted up a little bit. So let's see what we can find here. And this one, by the way, is y equals x squared. That's the parent function. All right, so what's our vertex here? Our vertex is 0, 2. You can see that from the graph. You notice you can also see it from the table because it's going down, 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 and it stops, and then it goes up, 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 up. The lowest point, or in some cases the highest point, is going to be your vertex. The axis of symmetry is the line x equals whatever the x value in the vertex is. I pointed out as we were drawing this that they have symmetrical points, or points right across from each other. So two of the symmetrical points would be -2, 6, and 2, 6. And you could do 1, -1, 3, and 1, 3. These are not necessarily always just going to be negatives of each other. Sometimes they'll be shifted. These couple examples I'm going to give you, they're all going to be negative, but that's not necessarily the case. And then the domain for all parabolas, unless it's changed by the situation, is all real numbers, because we can put anything in x. And the range on this one goes from the vertex, the y value of the vertex, either greater than or less than, in this case it's going up, y is greater than or equal to 2.